Hi everyone, today is Subtracting Rational Numbers Lesson 2.3. Please write that at the top of your composition notebook. And the essential question is, how can you use what you know about subtracting integers to subtract rational numbers? And as we go through the lesson, you might see that it is very similar. Okay, so the key idea is subtracting rational numbers is to subtract rational numbers, use the same rules for signs as you use for integers. So it looks like here that they used add op. Right here. Add op. Okay, oops, don't know why that did that. And I would just make note of that in your composition notebook along with all of these notes on this page. Okay, moving on. Okay, they want us to find this, and I'm going to make this into an improper fraction just because I feel like it's going to be easier to work with. Okay, so 4 times 7 is 28 plus 1 over 7. That equals 29 over 7. And we can't forget about the negative that is right here, so I'm going to put that right here. Then I'm going to write the rest of the problem as it's shown. Okay, and then from here I see that it is a subtraction problem, and we don't really like subtraction problems. We're going to want to make this an addition problem because that's just easier to work with. So I'm going to use add op. Add op. Okay. Now I have a negative 29 and a positive 6. And that's where we come in with our DS rules, which are different sign rules. Okay, so we're going to subtract, and we get 29 minus 6, and that gives us 23. Okay, and we take the sign of the larger, which is the negative 29. So that's going to be negative 23, and so over here this equals negative 23 over 7. Voila. Okay, and now it says find 12.8 minus 21.6. As usual, I don't really like that these are in decimal forms, so I'm going to make them into a fraction. That's the 10th place, and that's the 10th place as well. So I'm just going to write that up there. 10th place, 10th place. Okay, and then we will do this. So then you write the top number of the fraction, the number that's shown without the decimal, so it's 128 over 10 minus 216 over 10. Okay, and here we have the subtraction, which obviously we do not like because we've said this 1,000 times. So we're going to use add op. And that's going to give us now 128 tenths plus negative 216 tenths. So I'm going to use, this is a negative and that is a positive, so I'm going to use the different sign rules. So that's 216 minus 128. That's going to give us 88. We have to take the sign of the larger, which is 216, so this is going to be negative 88 over 10. However, this is not in simplest form, so if you wanted to leave it as a fraction, you would have to simplify it, but I'm going to put it back in decimal form since that's what they started with. So this is going to equal negative 8.8, and that is our answer. Okay, and now this just seems to be a lot of the same thing that I was doing, so just do some of these on your own, and please, if you have any questions, let me know in class. Okay, so this problem says find the distance between the two numbers on the number line. So here we have one number and here's the other one. You want to take the larger one, which is the 2 1/3, because this one right here is positive, so it's bigger than this negative one, minus, because you want to subtract, the negative 2 2/3. You guys know I don't really like mixed numbers, so I'm going to make it an improper fraction. So 2 times 3 is 6 plus 1/3. That gives me 7/3 minus, I'm just going to bring that down, minus 2 times 3 is 6 plus 2/3. That is minus negative 8/3. Okay, and then from here we don't like subtraction, so we're going to add up, and we get 7 plus 8, which I think we can all do by now, is 15/3, which equals 5. Awesome! Okay, so here we have a story problem. In the water, the bottom of the boat is 2.1 feet below the surface, and the top of the boat is 8.7 feet above it. Towed on a trailer, the bottom of the boat is 1.3 feet above the ground. Can the boat and trailer pass under the bridge, which is pictured right here? Okay, so I'm going to do the first part of this first, so we're just going to break this up into 2, okay? Okay. So I'm going to draw, but this is going to be really, really bad. So here's the water, and here's our boat, okay? I don't know. Imagine that's a boat. It's a really bad looking boat, but just imagine. Okay, so right here they say it's 2.1 feet underneath the water, and here is 8.7 feet. So if I do 8.7 plus 2.1, I am going to get, and since these are both positive and everything is nice, I'm just going to add them. I'm going to get that they're that the boat together with the underneath the surface and above the surface is 10.8 feet. So the whole boat itself is 10.8 feet. Okay, I'm going to erase this. Erase. Keep that. Erase. Okay. Now we're going to talk about the other half, which is this. So here's our trailer. Pretend those are wheels. I don't really know. And then here's our boat on top of it, which we said the boat is 10.8 feet. The trailer is 1.3 feet, because that is right here in the problem. So now we have to add that. So 10.8 feet plus 1.3 feet is going to give us, hold on, let me erase. Okay, and I'm going to start writing in a different color so we don't get confused. Okay, so it's going to give us 12.1 feet. But if you can't see how to do that, then just do your 108 over 10, because the 0.8 is 10th place, plus 13 over 10, that's going to give us, let's see, 108 plus 13. Mental math here. 121 over 10. And then you divide that and you get your 12.1 like we have been doing. Feet. Okay, so now it asks, the question that they're trying to answer is, can the boat and trailer pass underneath the bridge? If the bridge has this much clearing, the boat is obviously greater by 0.3, so it cannot go under. No, cannot go under that bridge. Okay, and that's it. You guys did a fabulous job, and I'll see you on tomorrow. I'll see you tomorrow.